Inspection is, like I said, this idea that you can just look at a situation and know what's going on. And maybe a good example of this is, let's say that you have a sphere, and that sphere is contained inside another sphere like this. So you have like these two spheres, possibly concentric, right? So the sort of perfectly aligned despite my drawing. And then the question is, if I go, let's call this surface 1, and let's call this surface 2. And I'm only like concerned with the radiation that's going from 1 to 2 or 2 to 1, like inside this space in here. All right, so think of this as like a solid in here, and then out here there's like solid. So we're only really concerned with what's like happening inside this space here. So if I look at this, if I'm surface 1, I'm emitting, where's all the radiation from surface 1 going to go? Right, it has to go to 2. So from surface 1 to surface 2, the view factor by inspection here, we'd say F1 to 2 is equal to 1. What about from 2 to 1? Is that going to also be 1? I'm seeing no's, right? Because you could theoretically have radiation emitted here that's absorbed by 2 again. So we don't actually know from this by inspection which is which, right? So F2 to 1, we don't know that one, right? We can't compute that by inspection. Some other examples. So let's say we have a plate like this, and this plate extends, let's say, infinitely to the left. And then I have another plate that's right here. And it so happens that this plate, let's call this L over 2, and let's call this L over 2, right? It sort of bisects the plate. So if I look at this and I want to know what's my view factor, so this being surface 1, this being surface 2, what's F from 1 to 2? By inspection, I could figure this out. Well, it turns out it's half, right? Half of the radiation leaving 1 is going to be intercepted by 2. And that's because of the symmetry of the problem, right? Either on the left half, it will certainly hit a plate. On the right half, it will certainly not hit anything. And so by inspection, we realize that F1 to 2 is 0.5. Actually, by inspection, as I've told you here, so if we know that this is infinite to the left, F2 to 1, what would that be? Sorry, question?
Can't radiation from the right side of the plate still cross over to hit the top plate?
Yeah, so the question was, can the radiation from the left still cross over?
Right side of the plate. Okay.
Yeah. So, but think about that. So like, let's say I have this situation where something crosses over and hits there. It is equally likely that something over here will cross over and miss, right? So for every possible situation, there's a mirrored situation on the other side. So by that sort of inspection, we can say it's half. Yeah.
So does that mean that the view factors are like an average of what it would be, since we're not exactly sure what it's actually is?
Yes, so the question was, is the view factor like an average of what would happen? Yes, the view factor is if you had infinitely many rays that were emitted, infinitely many photons that were emitted, that would produce the view factor, right? Any other questions? Okay. F2 to 1 in this situation. So what I've given you, it's maybe a little weird, but we can actually compute that view factor too, the infinitely long surface to surface 1. Anybody know what that's going to be?
0.
Yes. And do we know why it's going to be 0? Because it's infinitely long, right? So this is going to be 0. Or it's going to approach 0, right? So you kind of get the idea, right? There's more interesting situations that can happen. So you might have like a sphere like this, and then maybe you have some kind of half shell like this. So we're considering 1 and 2. We could say for surface 1, like F1 to 2, again, that's going to be 0.5, right? Just because of the symmetry of the problem. It's very much like the infinite surface one. F2 to 1, we don't know that one, right? We can't inspect that one. So this is the general idea. One thing to watch out for is like you don't want to maybe convince yourself that you're inspecting something that you're not. So don't invent the idea that you can be sure that you have it by inspection. You really have to think about it like, could I come up with cases where, like there's symmetry involved, or there's some principle I can apply that sort of proves to me that this is what the view factor has to be. All right. Okay, so that's the first category, this sort of low work required. You just sort of look at it and see what's going on.